The purpose of this lab was to analyze a star orbiting a black hole of unknown mass and determine the mass using Newton's law of universal gravitation. The main result was that the mass of the black hole was 2.61 times 10 to the 31st kilograms. The initial conditions were coded into the Python code. This includes the star's mass, the time step, and the black hole's position. These numbers respectively were 5.0964 times 10 to the 27th kilograms, 86,400 seconds, and negative 5 times 10 to the 10th, 3 times 10 to the 10th, and 0 for the vector for the black hole. As it orbited the black hole was provided on WebAssign. This data was iterated through to find the star's velocity as it traveled from point to point, using the formula final position minus initial position divided by the change in time. Using this velocity data, the initial and final momentum was solved for using the formula momentum equals mass times velocity, using the initial velocity for the initial momentum and the final velocity for the final momentum. From these calculated points, the change in velocity and change in momentum were found. These calculations were made in a while loop in the Python code to find the changing values in each time step. From here, Fnet, F parallel, and F perpendicular were found by using the change in momentum over change in time, or dp/dt, dp/dt parallel, and dp/dt perpendicular. Fnet was set equal to dp/dt. dp/dt parallel was solved for by finding the magnitude of the initial momentum and the magnitude of the final momentum, subtracting them, and dividing them by delta t. This was then multiplied by the unit vector for the momentum and set equal to F parallel. Since dp/dt parallel and dp/dt perpendicular must add up to equal dp/dt, the dp/dt perpendicular was found by subtracting the parallel from the total. Fnet perpendicular was set equal to dp/dt perpendicular after this was solved for, as shown here. These values were again solved for in each position by iterating through a while loop. This includes the v initial and the v final, the momentum initial and the final momentum, the delta v and the delta p, as well as the Fnet, the F parallel, the F perpendicular, and the corresponding dp/dt parallel, perpendicular, and dp/dt total. With the yellow arrow being Fnet, the blue arrow being F perpendicular, and the black arrow being F parallel. If the stars were to continue around the path, the F perpendicular would constantly be pointing towards the center of the kissing circle, while the F parallel would be tangential to the star's movement. The Fnet would be the addition of both vectors. The arrow scale was changed until the arrows were visible on the screen to show the representation of these forces, ending up with a value of 1 times 10 to the negative 11th. And as shown, the yellow arrow points towards the black hole. Newton's law of universal gravitation was manipulated to solve for the black hole's mass. The law of gravitation states that Fnet equals g, the gravitational constant, times the mass of the object 1 times the mass of object 2 divided by the radius squared. The radius is the distance between the two objects. The object 1 was the star in this case, and object 2 was the black hole. The formula was manipulated to look like mass of the black hole equals the net force times the radius squared divided by g times the mass of the star, where g equals 6.67 times 10 to the negative 11th. The final value found for the mass of the black hole was 2.61 times 10 to the 31st kilograms. Questions. For the what-if question, if the motion of the star remained unchanged and the distance between the star and the black hole remains the same, then the mass of the new black hole would be the same as the mass of the old black hole. This is the case since none of the values have changed, and the calculations would remain the same. What does it mean? The force values are different for the dp/dt values even though they are mathematically equivalent. The force values represent the interaction, while dp/dt values are the effect of the interactions. However, Newton found that both of these are mathematically equivalent, which is why they are set equal to each other in the Python code.